Alright, hello math fans. Alright, so today we're going to use some of the knowledge of trig functions that we've learned in the past here and figure a couple more things out here. Okay, so this is using trig functions. Alright, so I have a bunch of examples to give you guys. So here's the first example. Sine of theta is equal to 2/5. Okay, so the question is, what is cosecant of theta? Okay, well, of course, you know sine goes with cosecant because pilot goes with copilot, right? So that's going to be easy, right? That's just 5/2, and that's just because it's a reciprocal. And again, this is an exact answer. Okay, let's do another one. Cosecant of theta is equal to 1.63. And of course, I'm going to say, what is the sine of theta? Now, you can see it's a decimal, so you're going to give me a decimal answer. And just be careful when you put in your calculator. Remember, sine of theta is equal to 1 over cosecant of theta. Or you could write it the other way. Cosecant of theta is 1 over sine. It's the same thing, right? It's a reciprocal of it. Okay? So remember, what you're going to do is you're going to, just as it's written here, you're going to do 1 over 1.63. That's going to be your answer. Okay, that's really easy. So you don't have to do really any work here. It's just 1 over 1.63, which comes out to be 0.613. Okay, round it to 2 decimal places. And that's really good use of this key in your calculator. All right, here's another one. Tangent of theta is equal to √3 over 2. Of course, cotangent of theta is just reciprocal. Make sure you just rationalize it. 3 over 3, so you get 2√3 over 3. Okay, pretty easy. All right, so let's, with our knowledge of reciprocal functions, let's find a value of the variable. And it's tangent of parenthesis 2 theta plus 5 equals 1 over cotangent of 5 theta minus 10. Now again, you should know that tangent, just writing it out, tangent of theta is equal to 1 over cotangent of theta, right? So that theta is the same. So as long as I have it written that way, I can just set those equal to each other, and that's exactly what I have. I have tangent of theta equals 1 over cotangent. So I can say 2 theta plus 5 equals 5 theta minus 10. So move it over, I get 3 theta is equal to 15. Theta equals 5. Okay? And what about, here's an alternate setup. What happens if you have secant of theta plus 105 times cosine of 2 theta minus 5 equals 1? So what if you have something like that? You really don't have anything to set equal, but what you should realize is you can kind of manipulate this a little bit to have it look back to this, the reciprocal function, right? I can divide, really, both sides by cosine of 2 theta minus 5. All right, I could divide that, and then I get secant of theta plus 105 equals 1 over cosine of 2 theta minus 5. Okay, now I have a problem just like I did before. I set those equal to each other because they're reciprocal. So theta plus 105 equals 2 theta minus 5. So I move the theta over, and I get theta, and I add that 5 to both sides. I get theta equals 110. Okay, that's pretty easy. Let's talk about quadrants now. And yesterday we talked about the quadrantals. Okay, and where's sine positive and where's negative. So remember, if I write this out, the sine of theta. Do you remember this was sine of 0 is 0, Sine of 90 is 1. Sine of 180 is 0. And sine of 270 is negative 1. So if I look at the range is between 0 and 1 here. Do you guys agree that the sign is positive here, no matter what? So in that area, the sign is positive. And in this area, it's also positive because it goes from 0 to 1 to 0. And then from 0 to negative 1, it's negative. And from negative 1 to 0, it's also negative 1, or negative. Okay, so that's what sine looks like. And let's just do one for cosine. Okay, cosine of 0, this is 1. This is 0, negative 1, and 0. So between 1 and 0, it's positive. Between 0 and negative 1, it's negative. Between negative 1 and 0, it's negative. And between 0 and 1, it's positive. Because basically, what we're going to do is we're going to get values of, like here, it's 1. And then as we work our way around the unit circle, it's going to be 1 and 0.9, 0.90, 0.5, 0.3, 0.1, 0.001, right? It's all, these are all positive values. Okay, so that's for cosine. What about, let's talk about tangent. Because really, once we have that, do you guys agree that I know all my reciprocal functions because the reciprocal of a positive or negative is a positive or negative, right? That doesn't change. Only the value changes, not the sign. So let's think of tangent. Well, yesterday when we did this, we said tangent is 0, 0. This is undefined. This is 0, and this is undefined. Well, that doesn't really help us out very much, does it? Because what's undefined? I mean, where are we going here? But remember what I taught you guys yesterday. Tangent of theta is equal to sine of theta over cosine theta. Great identity. Okay, so that kind of helps us out. So the first quadrant, they're both positive. Positive over positive is a positive. Okay, the second quadrant, one of them is negative. So a negative, or a positive over a negative is a negative. The third quadrant, they're both negative. So negative over negative is a positive. And the fourth quadrant, sine is negative. So it's negative over positive, which is a negative. Okay, so those are the signs that you need to remember for sine, cosine, tangent, and then of course you get the reciprocal functions. Now let me show you kind of an easy way to remember that. Kind of a fancy way here. All students take calculus. This is for the signs of sine, cosine, and tangent. Okay, so this means they're all, and this is the signs. Actually, when I say signs, that means where it's positive. So they're all positive here. Sine is the only one positive here. Tangent is the only one positive here. And cosine is the only one positive here. That's how you remember all students take calculus. Or if you don't think all students are going to take calculus, you can always also take cookies. Okay, all students do take cookies. Maybe. So that's a great way to remember things. Just make a quick chart, and all students take calculus starting in the first quadrant, and you can figure out all your signs. Okay. So here, let me ask you a couple questions now. What is the quadrant? I'll put a parenthesis because it might be more than one. Satisfying. And we're going to do cosine of beta. We're just going to use a different letter here. Is greater than 0. And sine of beta is less than 0. So we basically look at our chart here. Where's cosine greater than 0? Well, cosine is greater than 0 in the first quadrant because they're all positive there, and also the fourth quadrant. Whereas sine beta less than 0, well, here I'm going to write this out. It's in quadrant 1 and quadrant 4. That's where cosine is greater than 0. Whereas sine of beta less than 0 in the third quadrant and the fourth quadrant. And it's and, so you're looking for the intersection of the two. Where are they intersecting? Well, they intersect at quadrant 4. So the answer to this problem is quadrant 4. Okay? Cosecant of theta is less than 0. And cotangent of theta is less than 0. Alright, so again, let's look at cosecant goes with sine, and cotangent goes with tangent, just to kind of help you that out there a little bit. Where is sine negative? Sine's negative in quadrant 3 and 4. Where's tangent negative? Tangent is negative in quadrant 2 and 4. And where do they overlap? In quadrant 4, so that's the answer, quadrant 4. Okay, last one, secant of theta is less than 0, and cosine of theta is less than 0. Okay, so where is secant, what does that go with? That goes with cosine. And where is it less than 0? It's less than 0, or it's negative in quadrant 2 and 3. Whereas cosine less than 0? Well, that's kind of a tricky one, right? Because it's the same thing. So where are they both true? In 2 and 3. Okay? So just a real quick question here. What is the sine? So I'll put the rest of the stuff right here. I'll say, what is the SIGN sine of the following? Cosine of 120 degrees. Well, isn't 120 degrees somewhere between 90 and 180? So isn't it somewhere in this area over here that's 120 degrees? Well, cosine is negative there, isn't it? So that's it. Okay, what about sine of negative 20 degrees? Now you could do coterminal and add 360, but why? We don't even need to do that. Really what we need to do is say, okay, it's negative 20 degrees, so we're somewhere down here. And I know sine is negative down there, so it's negative. And what about tangent of 1,000 degrees? Okay, this is where you do coterminal, right? So you could keep subtracting 360 and you wind up getting tangent of 280 degrees. Okay, so again, you got to be kind of good at this. This is, I'm going to do this in red here now. This is 90, this is 180, and this is 270. So 280 is going to be just a little bit past this, so we're going to be in this quadrant here. And tangent is negative there. Okay, so that's what the answer to that is, negative. Okay. Next type of problem is it's going to say find all trig functions. So find all trig functions when cosine of theta equals 3/5. And so that's an important part here. That's one part. And I have to also tell you theta is in quadrant 4. That's the second part. Got to have both parts. Because if it was just one part, cosine is positive in two parts. And you wouldn't know which one you know what the signs are. All right, so make a quick sketch here. We're in quadrant 4. And you know that, so we're going to write all students take calculus. So cosine is positive, everything else is negative in that quadrant. All right. You know cosine is x over r. So cosine of theta equals x over r. So x is 3, r is 5. Okay, what's y? Well, again, it's based off of this picture here. Right, we're in this quadrant, and isn't y negative here? So this is a 3, 4, 5 triangle. You can use Pythagorean theorem too, but y is negative 4. Okay, so that's really what you need for all this. And then it's easy. We have sine of theta is equal to y over r, so it's negative 4/5. Cosine of theta, which you already know, is 3/5. Tangent of theta is the yax, so it's negative 4/3. Cosecant of theta is just the reciprocal, so it's negative 5/4. Secant of theta is equal to 5/3. And cotangent of theta is equal to negative 3/4. Okay, that's not bad. Let's try one more example here. Now I'm going to tell you, again, finding all the trig functions, and cosecant of theta is equal to negative 2, and theta is in quadrant 3. Okay, so we're in this quadrant here. So again, I'm going to write all students take calculus. Well, we have -2. We need a ratio, so let's put it over 1. And again, help to remember cosecant goes with sine. So sine is y over r, so that's got to be r over y. Very important. Also important, I know that negative's on top, but it's not really negative on top, right? Because r is always positive, so that negative goes to the bottom. So it's truly negative. It's truly 2 over -1, if you want to look at it that way. Okay, so r is 2, y is -1, and then we use Pythagorean theorem. Okay, x squared equals r squared minus -1 squared. So x squared equals 4 minus 1 is 3. So x equals √3. All right, and we're in quadrant 3. So what does that say? That says x is -√3. That's important. Don't forget your signs. That is probably one of the biggest mistakes. People forget their signs, and then you get it wrong. Okay, so very, very important. Okay, so we got r, y, and x, so let's figure it out. Sine of theta is equal to y over r, so -1/2. Cosine of theta equals x over r, or -√3 over 2. And tangent of theta is y over x, which is -1 over -√3, which is 1 over √3. And if I rationalize it, I get √3 over 3. Okay, and then we have cosecant of theta. It's just reciprocal sine, which is -2, which we already know. It's from up here. Secant of theta is -2 over √3, the reciprocal. So that rationalize that, I get -2 √3 over 3. And then cotangent of theta is x over y. So it's -√3 over -1, which is √3. Okay, it's positive. Okay, and you know it's positive too because you're in that third quadrant, and cotangent and tangent are also positive. All right. Anyway, that's it, math fans. Hope you guys are good to go with that. This is the last unit before the quiz, and then the test after that. All right, that's it, math fans. Have a great day. Bye-bye.